All right, so we're doing another chapter on triangles. All right, have we done? Well, we just did the one triangle, right? Or the one chapter on triangles, chapter 4. This is another chapter on triangles. We have another chapter. I forget exactly which numbered chapter it is, but it's just on right triangles, nothing else but just right triangles, and another chapter on similar triangles. And who knows? There may be another triangle chapter in there somewhere. I'm not really sure. But they love the triangles. All right, it's not that bad. It's only 3 sides. How hard could it be, right? 3 sides, 3 angles. What's the big deal, right?
Exactly. So why are we doing so much?
Exactly. It's hard to believe that there's so much to do on triangles. Okay, let's talk about this though. Let's talk about this. This first little bit that we're going to do right here really doesn't deal with triangles necessarily, but we will get into triangles here in a second. So what I'm going to do is I'm going to draw a line segment from there to there. Okay, now this is a line segment, so it starts and it stops. All right, and I'll call this JK. All right, and then we have another line segment. Well, not a line segment, but a line. And watch what it does. Actually, what I want to do is this. Where do you think the midpoint is? Stop me when I get to it. There? Nah.
There.
Probably about.
Up more. To the left. To the left. Up. No. Right there. Right there. Right there. Right there.
Right.
No. Yeah. No. Over a little more. No.
All right, you're playing with me now. All right, that's what it's going to be. Obviously it is. Okay, look. What I'm going to do, I'm going to try to draw. I'm just eyeballing this right now. But how do you think I'm eyeballing this thing? So it's what? What do you think I'm trying to... Okay, that's fine. What do you think I'm trying to do with this line right here? I'm trying to make a right angle out of it, okay? So that's exactly what I'm doing. And you kind of help me out and try to find the what of this line segment. The midpoint, okay? And actually, they don't even put a letter here. Well, we'll call it M for midpoint. How's that? Now, this right here is a line. Now, it could be a line segment as well. But now, do I find the midpoint of a line? Because the line keeps on going in all directions. There's really no one point that's the midpoint of a line. Okay, so this is a line right here. So I'm not finding the midpoint of this. I'm finding the midpoint of JK. So if I wanted to, I could put a little tick mark here, a little tick mark here. Now, let's see what I did. Let's see what this line right here, we'll call it line RS. We'll call that R, and we'll call that S. This line right here does what to this line segment? Well, it bisects it, doesn't it? Okay, hits it at its midpoint, so it bisects it, and it's what? It's a right angle, so it's what to this line segment? Perpendicular. So guess what we call this thing? We call this a perpendicular what? Very good. Well, no triangles. Haven't even done a triangle. It's a perpendicular what? Just bisector. That's exactly right. All right. So there's 2 things that's going on. Listen, please. There's 2 things that's going on. There's one line is perpendicular to the other, and one line bisects the other. I shouldn't say bisects the other line segment, okay? So we can only bisect a segment. We can't bisect a line. You follow me on that? Okay, so if I have line JK, if this kept on going, I couldn't really say, oh, this is the midpoint of line JK. You can only bisect a line segment. You got it? Okay, now you can bisect angles, but we're not talking about that right now. We're just talking about lengths, about line segments. So that's a perpendicular bisector. Now, this is not the last you're going to see a perpendicular bisector. We're going to do a lot of this kind of stuff, and we're actually going to introduce this with triangles at the end of this lesson, hopefully. Hopefully we get there. Okay? So does everybody understand what a perpendicular bisector is now? It's a line, or it could be another line segment, all right, that bisects a line segment. We'll just say it's a line that bisects. It's not just bisect, but what? It bisects and is what? Perpendicular to that line segment. 2 things. Everybody got it? And it's right there in the word. There's 2 things. It's perpendicular and it's a bisector. So it hits it at its midpoint. All right. Now, with all that said, let's get rid of this right there. And let's draw something else. All right. So I've tried to draw another perpendicular bisector. Let's just kind of scooch this up a little bit. A little more towards the middle. All right, I tried to draw a perpendicular bisector, so AB is being bisected, isn't it, at point D, and we'll call this C right here. So line CD, if you want to say it, line CD is the perpendicular bisector of line segment AB. You with me? If you wanted to write that down, say line CD is the what? Perpendicular. I'll shorthand it a little bit. Perpendicular bisector of what? Do I just put AB? It's line segment AB. Okay, so I write it like that. All right, so that's what's going on right here. Now, we have a theorem. It's called the perpendicular bisector theorem. How about that? Perpendicular bisector theorem. And basically it says this. It says if I have a point on the perpendicular bisector. Now what is actually doing the bisecting? Is it AB or is it CD? CD is actually doing the bisecting, right? CD bisects that segment. So CD is my perpendicular bisector. And it says if there's a point on the perpendicular bisector, then, watch this, it's equidistant from the endpoints of that segment, which means what? Now it's a little wordy. You don't have to memorize what I just said, but tell me, Demir, what is it? If I drew from C to what? C to A, right? And then I drew from what? C to what? B. Guess what should be true about those two segments? Okay, they should be equal to each other. Exactly right. So I could say that this and this. So what did we start with? We started knowing that AD and BD were equal to each other, correct? We knew this was a right angle. If I know that, look, I could take any point on this perpendicular bisector and it's going to be equidistant from the endpoints of that segment. For instance, I could have put another point like, I don't know, let's put it down here just for fun. Come on, what am I doing? Alright, I don't know what's going on. Here we go. What if I put a point like right here? And we'll call it point E. What could I say? And we'll do a different color here. Go blue. What could I say about that point? That point lies on the perpendicular bisector, doesn't it? So that must mean what? It's equidistant from the endpoints. So I could say what? EA equals EB. Right? You with me? I could put a ton of points on this perpendicular bisector, and wherever that point is on that perpendicular bisector, if I take it and connect it to the endpoints of the line segment, do you hear what I said? The endpoints of the line segment is line segment AB, so if I connect anywhere, if I extended this line up, if I wanted to, okay, and I wanted to put some point like way up here like this, and if I connected this point to A and this point to B, guess what's going to be true about those two line segments? They're going to be equal to each other, going to be equidistant, correct? Does that make sense? All right. So this is what I wrote, just to help me out a little bit. We'll start with that first one, that red one. So if C lies on the perpendicular bisector, sorry about my writing, of line segment AB, then, put a comma here, then AC must equal BC. The length of. When there's no line segment over top of it, it means the measure of, or the length of AC is equal to BC. Are you with me on that? Okay. Now that's the perpendicular bisector theorem. All right, so if we have a point that lies on the perpendicular bisector, it's equidistant from the endpoints of that line segment. A little wordy, but this kind of helps you out a little bit, makes it a little bit easier to understand, I think. You with me on that? Okay, what if we do this? Now, what was given to us? It was given that this was the perpendicular bisector. So it was given, now we're not going to prove this, don't get all scared when you see this, okay? It was given that what? That AD equals what? BD. And it was also given that CD was perpendicular to AB. You with me? So it was given that these two segments are equal, that means it's a bisector, and it was also given that CD and AB were perpendicular, that means perpendicular. So what do we have? We got a perpendicular bisector. We were given that it was a perpendicular bisector. Are you with me? I'm going somewhere with this, so follow me. I was given that this was a perpendicular bisector, that means these two lengths right here, from this point to the end points, are going to be equal. What do you think we switch it around? This is not the first time we've done this. We've done this quite a bit with theorems. We take the theorem and then we take the if and the then and we switch it around. What do we call that if we switch the if and the then around? The converse, exactly right. Okay, it's the converse of this. So let's get rid of some of this stuff that I don't really need. All right, get rid of that. All right, that's good enough. What if we actually, I'm going to keep the same picture. If you want to redraw this picture, you can. It just might be a little easier if I do this. All right. Here's the situation now. Now that's the bisector theorem. Let's do the converse of it. The converse of the Sure, why not? Of the perpendicular bisector theorem. Okay, so we want to do the converse. So what do we do with the converse? We change the if and the then. So instead of saying if the point lies on the perpendicular bisector, what are we going to say? If what? That's right, if AC equals BC. So we don't know that this is a perpendicular bisector just yet. All right, so this is all we know. We know that we have a line that intersects a line segment. That's all we know right now, okay? I don't know that this is equal to this, do I? Not yet. I don't know that it's perpendicular. Kind of looks like it, but I don't know it is. Okay? What do I know? What's the if part? The if part's the given. So this time, I'm given what? That AC equals BC. So I'm told that. All right, let's mark it. AC equals BC. That's what I know. You with me? What then do you think I can say about point? Or what do you think I can say about this line and this line segment right here? If AC equals BC, where do you think line C actually lies then? Because watch, if I took this point and I slid it over here, would AC equal BC? No. If I slid it over here, would they equal each other? No. They only equal each other when it's right here. If it's right here, guess where that point lies then? It lies on the... Now, think of the if-then stuff. Remember? We switch them around. If AC equals BC, then what? C lies on the perpendicular bisector of AB. Exactly right. Do you see the difference on that? You're given different information. You're not given that it's a perpendicular bisector at first. You're given that AC equals BC. So then what can you say? You could say, watch, then you could say point C lies on what? The perpendicular bisector of line segment AB. You see the difference? The first part, we tell you it's a perpendicular bisector. I tell you two things. I tell you it's perpendicular, and I tell you it's a bisector. So what can you say about point C? You could say point C, well, you could say that AC then would equal BC. Right? That's the theorem itself. Then I say, okay, let's switch it around. Let's take the if and the then and change places with it. So now I know that AC equals BC. That's all I know right now. So if I know that's true, what can I say about this line? I can say that this line right here is a perpendicular bisector. So I can say now, since I know that this and this are equal, now I can say, well, that's perpendicular and that right there, those two things right there are equal to each other. Do you see it? Does it make any sense at all? I'm getting glazed looks. Okay? No, I don't blame it on Monday morning. I don't have a glazed look. I'm a wide awake, okay, and I'm not even a morning person, but I can still do it. So I don't blame it on Monday. Let's pay attention. Don't blame it on anything. I blame it on that you refuse to try to learn this stuff if you're not learning it. Okay, that's what I blame it on. So there we go. We got two things. We got a perpendicular bisector theorem, and we got the converse. All right, keep that in mind. Let's do a quick example. There's actually several examples in the book. I tell you, just because of the time's sake, it's not that difficult at all. You look at example 1, you can follow along. It's on page 323, okay? And you can look at the examples. I was going to show you, but we're just kind of running short on time. Here we go. This is a quick vocab word. We're going to use this a little bit, so I don't want you to understand what's going to happen. I've got 3 lines right here. What do you think is true about all 3 of these lines? What do you think they do? They all, well, not bisect each other. They're lines. The lines can't bisect. They just intersect each other. That's right. They just intersect each other, okay, at a common point. I don't know. We'll call that point P. All right? So these 3 lines all intersect each other at point P. We give that a name. We call them concurrent lines. All right? It's just vocab. Just want you to know what that means, okay? Concurrent lines means, it means 2 or more lines that actually intersect each other. If they all intersect each other at a common point, then they're concurrent lines. This is not necessarily midpoint because they're lines. Can you have a midpoint of a line? No, you can't. Okay, so this is just a place, a point where they intersect. Now that point P is called the point of concurrency. See if I can concurrency. All right, so there you go. Point P is the point of concurrency. That's what you have to know about that. All right, I may get another video in. I think we got time. I got to do one more thing.